All right, this is 3.5. So this is the part 2 of the setup of the parent functions in 3.4. Let's get to it because it's a lot. So there are transformation rules for functions. We are going to go over all of them in this lecture, and then we're going to practice them, okay? So what you have is you have your original f of x, and then there are the possible things you can do to that parent function or the common function. Okay, and they are outlined here. So here is our original function, and here is the ways we can transform that function. 1 second. All right, I wanted to just explain the possibilities. All right, so here's just general function. Y equals x, y equals the square root of x, y equals the absolute value of x, those things that we talked about in 3.4. Here is the transformation, okay? If you put a number in front of, these number, okay? If you put a number in front of the entire function, what you're doing is vertical reflections, stretches, and compressions. Okay? If inside the parentheses you put a number next to the x, which means obviously multiplication, then that is going to be a horizontal reflection, stretch, or compression. All right. Then these are shifts, okay? If inside your parentheses you are adding or subtracting a number, that is going to be a shift of that many units in the horizontal axis, okay? So H is a horizontal, I should call it C, because down here they call it C. Horizontal shift, that number of units, opposite direction of sign. Okay. And then finally we have K, or D, it should be, because on this table down here, that's C and that's D. So that should be C and that should be D. D is a vertical shift. So on the y-axis, up and down, vertical shift K units, same direction as your sign. So that's just a little introduction. So say you have y equals x, all right? Y equals x. If you say y equals 2x, what's happening is y equals, we're going to then stretch the graph of y equals x by 2, okay? If we say y equals 2x plus 4, then we are going to move it up 4 units on the graph. All right, so this is just an introduction. It's going to be This is going to be helpful to you, and this is going to be helpful to you. I would suggest using this on the exam. I would also suggest just continuing to use Desmos a lot as we go through these ideas, okay? And I'll try to, yeah, we'll just try to practice it best we can. So here is the original function. Here is what we're adding to it. So in this example, we will add the k or the d. So we're adding d. We're going to subtract d outside the parentheses, okay? Adding c or subtracting c inside the parentheses means that it's affiliated with the horizontal shift or with the x. But outside the parentheses means it's associated with the y, so it's up and down, okay? These are associated with y, so they're up and down. These are associated with x, so they're left and right. A negative means we're reflecting that entire equation over the x-axis. A negative inside the parentheses are only affiliated with the x instead of both the x and the y, means we're reflecting it over the y-axis. A number, like I said, a number in front of the whole situation means we're going to stretch it or shrink it on the y-axis. And then if we put that number with only the x inside the parentheses, then we will just be stretching it or compressing it on the horizontal axis, okay? If you would just want to do it, you don't want to picture the graph, but you want to say, how do I need to change the coordinate point? If you're translating it up d units or k units, up k units means we add that number to our y value and keep our x point the same. Subtracting d means we subtract that point from our y value, keeping x the same. Horizontal translation, remember that the plus c for horizontal means we subtract that from x. So we're going opposite direction of the sign. Okay. And then if we're subtracting c, we're going to go to the right. So we'll add that many units to our x-axis, to our x value of the point. Translation over the x-axis, we already know that, makes the y into an opposite of that. Putting the negative sign just within the x, so making that a negative bx, will reflect it over the y-axis, so our x will become a negative x. And again, if you are changing all of f of x, you change the y accordingly. If you're changing just the x, you change the x accordingly, but remember, just like horizontal means the opposite, here, instead of multiplying that change, you're going to divide by that change. Okay, let's practice this. There's a lot of information in that introduction. Let's start with vertical shifts, okay? Vertical shift are these two, fx plus d, fx minus d, fx plus k, fx minus k, f of x plus k, f of x minus k, okay? So we're talking about these two. We're either moving it up or down on the x-axis, okay? Y equals f of x plus k is the graph of the parent function shifted up k units. Y equals f of x minus k is the graph of the parent function shifted down k units. Good. Let's describe each of these transformations in sketch. I didn't leave us much room because I wanted to get all of that nice and big for you so you didn't have to print it off yourself or copy it. Okay, so g of x equals the square root of x plus 2 is our first example. After 3.2, we have memorized what the square root of x looks like, right? So our parent function, or the common function, is just g of x equals the square root of x. That graph looks like this, right? That's g of x is the square root of x. Then we are saying plus 2. We are going to shift it up 2 units, okay? What are some points on g of x equals the square root of x? Well, we know that 1 and 1, right? 0, 0. The square root of 1 is 1. The square root of 4 is 2, right? So those are 2 points. And instead, we are going to shift it up k units. If we look at our little table, Shifting it up k units means we add that number to our y value. So instead of 1, 1, our new point is going to be 1, comma, 1 plus 2, so 1, 3. This one is going to be 4, 4. So we have moved it up. It's staying the same size. It's doing the exact same thing. It's just going to go up 2 units. Okay? Let's look in Desmos. Here is the red is just the square root of x, and then the blue graph is the square root of x plus 2. So instead of 0, 0, you have 0, 2. Good. So that is how you would sketch the transformation. How would we describe it? What happened here? The graph of the square root of x moved or was transformed up 2 units. Units on the y-axis. Good. All right. F of x equals the square root of x. Sorry, I guess I should have started in the middle. This is just the parent function. All right. What if we have the square root of x minus 2? Right? Again, let's start with g of x. Equals the square root of x is going to look like this. I guess I don't need 4 quadrants, right? I just need 1. Well, I need 2 this time. So we have that guy. That's our original g of x. Parent function is the square root of x. And then we're going to say minus 2, so we're shifting it down. So this point again was 1, 1. This point again is 4, 2. And now we're moving the y's down. Okay? So that's going to become 1, 1 is going to now be 1, 1 minus, oh, sorry, you can't see that. 1, 1 becomes 1, comma, 1 minus 2. So that's 1, negative 1. 4, 2 is going to be 4, 0, because 2 minus 2 is 0. So that's now the graph of g of x is the square root of x minus 2. Okay? How do we describe that? The graph of, so this is the parent function of the square root of x. This is that same graph of the square root of x, but we moved it up 2 units on the y-axis. Here is the graph of the square root of x moved down 2 units on the y-axis. Good. All right, so those are called vertical shifts because we are just shifting them up and down. Better said up or down. Now, horizontal shift, remember that horizontal shifts, we move opposite the direction of the sign, and similarly, horizontal reflections, stretches, and compressions are also the opposite. They also are divided by instead of multiplied. Okay, so when we're dealing with x, when we're dealing with inside the parentheses, you're doing the opposite of what it looks like you would be doing. Okay, it looks like we would be moving this one down 2, we move it down 2. It looks like we should be moving this one up 2, we move it up 2, right? Plus k is shifted up, minus k is shifted down. Horizontal is opposite. Okay, A horizontal shift, you know it's horizontal because it's inside the grouping symbol. So f of x minus h, the quantity, okay? G of x equals the absolute value of x minus 2. G of x equals the absolute value of x plus 2, okay? Let me show you, just with our first example, the difference between a horizontal shift is the square root of x plus 2. Another horizontal shift, the other one we did, is the square root of x minus 2. And then a vertical shift is the square root of x inside the grouping symbols. We put the plus 2 and it moves it now on the horizontal axis, okay? And notice that x plus 2 moves it in the negative direction. X minus 2 moves it in the positive x direction. So that's what we mean by it's a horizontal shift. It's within the grouping symbol. In this case, the grouping symbol is not the parentheses, it's the radical. Okay? And it does the opposite. So when we add 2 inside the parentheses, we move in the negative x direction. When we subtract 2 inside the parentheses, we move in the positive x direction. These are important things to see the difference between. Okay, so g equals f of x minus h is the graph of the parent function shifted right. Okay, so negative we shift right, and plus h shifted left. At least I didn't make it too confusing. I just copied the same thing twice. Good? Okay, so these are within the grouping symbols because the grouping symbol is the absolute value bar. Good? Okay, so our parent function here is the absolute value of x. And from 3.4, we know what the absolute value of x graph looks like. Again, we don't need a negative. We don't need negative y's. So the absolute value of x is graphed just like the linear x, y equals x, but only in the positive direction. So both ways positive. Okay, so that's just g of x equals the absolute value of x. Now, how does g of x equals the absolute value of x minus 2 change it? And you can go straight to Desmos. Don't hesitate going straight to Desmos, okay? So those are all our x, the square root of x's. Here we have the absolute value of x. Let's just look at the absolute value of x. And then let's look at the absolute value of x minus 2. Good. So x is right at the origin, 0, 0, and then x minus 2 moves in the positive 2 direction. Okay? So g of x equals the absolute value of x minus 2. Let's look at that little chart, okay? If we are subtracting the h inside the parentheses, if we are subtracting the c inside the parentheses, that means we add that many to our x value, all right? So let's find some x values and then add that number to them, okay? So here we have 0, 0. Maybe this is 2, 2. And then over here we have negative 2, 2, right? For this one, we're going to add 2 to our x values. So instead of 0, 0, we're going to have 2, 0. Instead of 2, 2, I'm going to have 4, 2. Okay? Instead of negative 2, 2, I'm going to have 0, 2. It should look the same. I know it doesn't, but it's because I'm bad at graphing. So this is just the parent function. How did I write it? The graph of. If we had to describe it, we would say this is the graph of the absolute value of x moved 2 units right on the x-axis. Good. All right, let's do x plus 2. Our next one is g of x equals the absolute value of x plus 2. So again, we're going to take that parent function. We're going to take that parent function, and now we have x plus c. We're going to do a horizontal translation left c units or left 2 units. So x, that c is going to be subtracted from x. So instead of 0, 0, we are going to have -2, 0. Instead of 2, 2, we're going to have 0, 2. And instead of -2, 2, we're going to have -4, 2. Okay. So this is the graph of the absolute value of x moved 2 units left on the x-axis. Make sure you can associate the x-axis with horizontal. Horizontal shift means we're talking about left and right. So those are our shifts. Type of transformation, we've done a vertical translation up, translation down, horizontal shift or translation left, horizontal translation right. We're now going to cover reflection over the x-axis, reflection over the y-axis, vertical stretch, vertical compression, horizontal compression, horizontal stretch. The timing was not right there. Okay. Dang, we're jumping right to f of x equals quantity x minus 3 squared plus 2. Okay, so what you want to start with is just like we started with example 1 and example 2, identify the parent function, identify how you changed it, right? We moved it 2 up on the y-axis, we moved it 2 down on the y-axis, we moved it 2 to the right on the x-axis, we moved it 2 to the left on the x-axis. So just keep this with you, okay? Decide what your parent function is. So our parent function is f of x is equal to x squared, okay? Because x squared, and then we subtract 3 inside the parentheses and we add 2 outside the parentheses. So my parent function looks like this. Right? Okay, x minus 3 squared. Let's talk about some points on this graph. This will have the point 0, 0, and then 1, 1, -1, 1, 2, 4, -2, 4, right? Those are all points on the parent function. Now, if we're subtracting 3, right, inside the parentheses, subtracting 3 inside the parentheses, that means a horizontal translation right, that number of units. So we're going to add 3. Okay, it's a -3, but we're going to add 3 to every x value. So -2 plus 3. Let's start with 0, 0. Okay, so we had 0, 0. Now we're going to change that to 3, 0. 1, 1 is going to become 1 plus 3 is 4. 4, 1. 2 plus 3 is 5, so that's 5, 4. Okay, negative 1, 1, negative 1 plus 3 is 2. So that's 2, 1. Negative 2 plus 3 is 1. Okay. Oh, I'm sorry, you couldn't see that. So this would be the graph of f of x is equal to x minus 3 squared, right? Instead of 0, 0, we have 3, 0 because we're moving 3 to the right. 1, 1 becomes 4, 1 because we added 3. We added 3 to the 2. We added 3 to the negative 2. We added 3 to the negative 1. Okay, and now we need to add 2. So from here to here, that's the negative 3. And now we need to graph. What if it would look like if this one then got plus 2 added? What does plus 2 mean? It's quite intuitive. Plus 2 means we're going to go up on the y-axis. So we're just going to say 0 plus 2, 1 plus 2, 4 plus 2, 4 plus 2, 1 plus 2. Okay, so instead of 3 comma 0, we're going to call it 3, 2. Instead of 4, 1, we keep it at 4, but this is going to be called 3. 5, 4. So we're adding 2. So it's going to become 5, 6. Good. 2, 1. We're adding 2 to the y value. So instead of being at the line 2, at the line y equals 1, we're going to be at the line y equals 3. So it's 2, 3. And then 1, 4, we're going to add 2 to the 4. So it's going to be 1, 6. So it's that same parabola going in the same direction, staying the same size, but we moved it to the right 3 and up 2. So this part meant 3 to the right, horizontal, okay? Guess I need the plus sign too. And that part means 2 up. Vertical shift. We moved it, so it is the graph of x squared shifted horizontally three units to the right and vertically 2 units up. Good. All right, as we get into these that have more than one change, it is important to go over the order of operations for doing applying transformations, okay? So you want to start with parentheses. Horizontal shifts, okay? Then do the multiplication. Then do negation. And then do Addition, subtraction. So start with parentheses means horizontal shift. First. Then multiplication is going to be your stretch, compress, to stretch or to compress. Negation is going to be, are you reflecting it? And then do reflection. I don't like reflecting. Horizontal shift, stretch, compress, reflect. Oh, we can just go with the reflect. Stretch, compress, reflect. And then, excuse me, that last addition and subtraction is your vertical shift. So horizontal shift, stretch, compress, reflect, and then vertical shift. Okay? Important. Important to do it in the right order because on certain occasions that could, you could get a different answer, kind of like with the order of operations for solving anything in math. You can get the wrong answer if you don't go in the correct order. It's not intuitive what the correct order is it necessarily? No. All right, so that was f of x equals the quantity x minus 3 squared plus 2. Oh, I didn't mean to draw on that. The minus 3 caused us to move it 3 to the right. The plus 2 outside the parentheses caused us to move it up 2 after that, okay? F of x equals the absolute value of both x plus 4, quantity x plus 4, and then minus 3 outside that grouping symbol, okay? So the plus 4 is a horizontal translation, and then the minus 3 is a vertical translation. You know that because these are grouped. These are outside the grouping symbols, right? What is the parent function? The parent function is just f of x is the absolute value of x, yeah? What does that guy look like? He looks like this. He is not a parabola, he is just a linear equation, but flipped on the y-axis and never crossing the x-axis. Okay, so that's our parent function. We probably need some points for that parent function because that's how we shift things. 0, 0, 1, 1, negative 1, 1, maybe 2, 2. It's getting a bit cramped. Negative 2, 2. Good? All right. Start with parentheses. Start with your horizontal shift. My horizontal shift is plus 4, so that means 4 to the left. Move it 4 to the left. And then we're going to go back and move it 3 down instead of 2 up, okay? 4 to the left. Anyway, too late. Why would I make the bottom bigger than the top? So here was our original, 0, 0, negative 1, 1, 1, 1, right? 4 to the left means I'm going to go all the way over from 0, 0. Plus 4 means subtract 4 from the x, okay? So from 0, 0, I'm going to go to negative 4, 0. From negative 1, 1, I'm going to go to negative 5, 1. You can't see any of that. From 1, 1, I'm going to go to negative 3, 1. So it's still on my same, all my y values are the same. My x values got moved 4 to the left. All right, now that minus 3, oh, sorry, let's graph what this is. So this is f of x is equal to the absolute value of x plus 4. Now, subtract 3. So subtract 3 means we're going to go down. When I had -4, 0, I'm now going to go down 3 and call it -4, -3. -3, 1. Up here, we're going to go down 3. So that's going to be -3, -2, because 1 minus 3 is a -2. And then we're going to have, instead of -5, 1, we're going to go down 3. We're going to say that's -5, x remains the same, -2. So what was once right here at the origin, we moved 4 to the left, 3 down. That +2 meant 2 up. This -3 means 3 down. How would I describe this? This is the graph of the absolute value of x shifted. What did we start with? Horizontally. Four units to the left, and vertically 3 units down. Okay, let's graph these in Desmos. So here is x, the quantity x minus 3 squared plus 2. You can see it is the graph of x squared. But what happened was, instead of the origin, we moved the vertex of the parabola from the origin. We moved it 3 to the right and 2 up. Here's 3 to the right, 2 up from there. It is the same in every other way, okay? Shifted. Then we have the absolute value of x plus 4 and then -3. So we can see that that original absolute value of x, that origin, the point that was the origin, is now moved 4 to the left, 1, 2, 3, 4, 3 down, 1, 2, 3 down, and there's that point. Instead of being the point 0, 0, it's the point -4, -3. So as usual, as always, I should say, Desmos is a valid way to answer all of these questions if you prefer it. Vertical, compression, or stretch. So we have learned how to do the horizontal shift and the vertical shift. Now we're going to talk about stretching and compressing. Reflection is just flipping it across the x-axis or the y-axis. Vertical compression or stretch. Y equals AF of x is obtained by multiplying each y coordinate of the parent function by a. If a is between the numbers 0 and 1, it is made smaller. If it's bigger than 1, it's made longer, not longer, taller by that many, okay? So for example 4, describe the transformation and sketch it. G of x equals, so I guess we have to, okay, describe then sketch. G of x equals 4 square root x. Look at this so that you can tell the difference between 4 square root x is this guy, and then the square root of 4x would be this guy. So this is AF of x, and if you had something like the 4 under there, that would be f of b of x. Okay, it's important to see the difference. So these are vertical because they are outside the grouping symbols. This guy is horizontal. Because he is inside the grouping symbol, he's associated with the x. This is outside the grouping symbol. Outside the grouping symbol is associated with the f of x, which is the y. So it's associated with the y. So if a is greater than 1, it is a vertical stretch by a factor of 4. So this is the graph of the square root of x stretched vertically by a factor of 4. Good. Then we can graph those. So here was our original. That's just the square root of x, okay? What are some points on the square root of x? The square root of x will include 0, 0. It will include that the square root of 1 is 1. And it will include that the square root of 4 is 2. Right? Okay, now, vertically stretched by a factor of 4 means we're multiplying each y value by 4. Okay? So, on this new graph, multiplying each y by a factor of 4, so I don't think I need quadrant 3 or 4, I'm just going to use quadrant 1 and 2. Instead of 0, well, 0, 0 is just going to remain 0, 0, because 0 times 4 is 0. 1, 1 is going to be 1 on the x-axis, but it's going to be 4 on the y-axis. Because we're stretching it by a factor of 4. So that 1 on the y is now a 4, because 1 times 4 is 4. That 2 is going to become an 8, right? So 0, 0, 1, 4, 2, 3, 4, 1. That's going to be an 8. We're stretching the y-axis by a factor of 4, so we're just making it really, really tall. But the x values stay the same. So that is, I didn't even remember, the 4 is outside. 4 square root x. Good? Okay. G of x equals 1/2 x squared. If the number is between 0 and 1, so if it's a fraction less than 1, then we are going to shrink it, okay? But regardless, all you're going to do is you're going to take your y value and multiply it by. So when we multiply a number by 4, it gets bigger. When we multiply a number by 1/2, it gets smaller. So you don't even need to remember y, right? It's just I'm going to multiply my y by that, and my graph's going to be smaller. The reason you know it's not a part of, the reason you know it's not a horizontal stretch or compression is because there is a difference between 1/2 x squared is outside of the parentheses, but 1/2 x squared is inside the parentheses. Okay, so that 1/2, the squared is not being applied to the 1/2. That's how we know that it is a horizontal instead of a vertical stretch or compression, because it's a compression, right? We made it smaller. Go back to Desmos. There's 1/2 x squared, and then there's x squared. You can see that x squared is taller than 1/2 x. So we are compressing it. This is the graph of x squared compressed vertically by a factor of 1/2. So we know what x squared looks like. And eat those arrows. X squared looks like this. Here's the point 0, 0. 1 squared is 1. -1 squared is 1. 2 squared is 4. -2 squared is 4. But now we're going to take all of those y values and divide them by 2. Okay, so my x values stay the same. So that's still going to be 0. And then we're going to take that y value and cut it in half. So 0 and then 0 divided by 2 is still 0. 1 comma, instead of 1, it's going to be 1/2. So we cut it in half. 1, 1/2. 2, what's half of 4? 2. 2, 2. So we've just made it a shorter squatter parabola. It's that same graph, we compressed it by half. Now let's talk about horizontal compression or stretch. Remember, it's going to do the opposite. So instead of multiplying your x value, you're dividing your x value by that number. Okay? So the difference is that this 2 is next to the x, so it's within, this will be horizontal. Because the 2 is right next to the x, but this one is vertical. The 2 is next to, so to speak, the whole y. F of x is y, right? So it's next to the y instead of just next to the x. So we say that the horizontal compression or stretch is obtained by multiplying each x coordinate by 1/a. You can also let's just call it that. If it's greater than 1, that means we're going to shrink it because that is now a fraction with that number on the bottom of the fraction as the denominator. If it's between 0 and 1, it's going to stretch because what was on the bottom of the fraction is now the number we're multiplying by, okay? So if this is the graph of f of x, what would it look like if we stretched it vertically by 2? And then what would it look like if we shrunk it horizontally by 2? Because remember, this 2 means a bigger vertical number, but this 2 means actually a smaller horizontal number, okay? Because remember, the x-axis is kind of doing the opposite of what you think it will. You think it would make it twice as big, it makes it half as big. It doesn't make it twice as big vertically, it makes it half as big horizontally. So let's look at that table of the transformation rules, okay? We have, let's start with the horizontal. It's what we're focused on. So f of b of x is f of 2 of x. So what we need to do is take x and divide it by 2. So all of our x values now get divided by 2. What are our x values? Pi over 2, right? That's an x value. 3 pi over 2, that's an x value. Negative pi over 2, that's an x value. Okay, even this guy, pi, 0, 0, it's not really going to change, and negative pi. Okay, those are going to be, when we look at this, f of b of x means we're taking x and dividing it by b. So we're taking all of those and dividing by 2. Divide all x values by 2. And as you can imagine, for the vertical stretch, we're going to multiply all y values by 2. But first, let's do this one. So instead of 0, 0 will remain the same. Instead of pi over 2, negative 2, we're going to divide pi over 2 by 2 and get pi over 4. So that's now going to move right over here. Okay? This guy, pi, is going to get divided by 2. So that's going to be right here. 3 pi over 2 divided by 2 is 3 pi over 4. So that moves here. Good. Negative pi over 2 becomes negative pi over 4. And then negative pi becomes negative pi over 2. So you have the same height, but we go through the origin still, but we've shrunk our graph horizontally in half. Okay? So that's what it looks like if it becomes y equals f of 2x, okay? Now 2f of x, vertical, what does that mean? The 2 is outside of the f of x, just like the a, and so we're gonna multiply y by that a. So now all our y values get multiplied by 2. Vertical means our y values, so that 2 is gonna get multiplied by 2. That negative 2 is going to get multiplied by 2. I guess that's all we've got is a 2 and a negative 2. That 2 is going to get multiplied by 2 and become a 4. That negative 2 is going to become a negative 4. Maybe more like that. And that 2 is also going to be a 4. So we're going to cross the x-axis at the same points, but we're just bigger along it, okay? So we still start here. We go all the way up. We still cross through the origin, but instead of stopping here, we go all the way down to here. We're still going to cross at that pi. We're going to come up here. Good? And so that is a vertical shift versus a horizontal shift. They both have the same number 2. Horizontally, that shrunk like this 2. Vertically, that stretched like this 2. Okay, reflection about the x-axis just means if you put a negative in front of the whole f of x, then the parent function is reflected about the x-axis. Remember our order, okay? So the order is that we want to do the horizontal shift first, then stretch and compress, then reflect, and then do that vertical shift, okay? So if you just have a negative in front of the whole thing, then you're reflecting it on the x-axis. All the y values become their opposite, okay? Y equals negative f of x. You know it's a negative because the negative is outside of the grouping symbol being the radical. So a negative outside, reflect over x-axis, make all the y's into the opposite, okay? Sketch the graph of the function. So we had our parent function. I'm going to do a graph of our parent function, and then I'm going to do a graph of the reflection. So this is going to be f of x is equal to the square root of x, and then this one will be f of x is equal to negative square root of x, okay? All your y's become negative y's. Square root of x, we had 0, 0. We have 1, 1. And then we have 4, 2. All of your y's become negative. So you still have 0, 0. But now instead of 1, 1, you have 1, negative 1. Instead of 4, 2, you have 4, negative 2. That is the function reflected across the x-axis. Here is the square root of x. Here is negative square root of x. Okay, and here is even square root of negative x is going to be reflected across the y-axis. And here we go, reflection about the x-axis. If it is inside the grouping symbols, you're going to reflect it about the y-axis, multiply the x value by -1, or make the x's opposite, okay? Sketch the graph of the function f of x equals the cube root of negative x. Parent function. Transformed function. So for f of x equals x cubed, we know, just from memory, right, that it looks like this. We know that it'll be 1, 1. It'll be 2, 8. -1, -1. -2, -8, right? And then here we're going to say f of x equals negative x cubed. That means the negative sign is within the grouping symbols, so my x values become negative x values. Instead of 1, 1, it's going to be -1, 1. Instead of 2, 8, it's going to be -2, 8. Instead of -1, -1, it's going to be 1, -1. Instead of -2, -8, it's going to be +2, -8. So I've switched my I have switched the sign of all of my x values and therefore have reflected it across the y-axis. Example 8 asks us to find the, so I think we've covered it all, right? We've covered horizontal reflections, stretches, and compressions. We have covered vertical stretches, reflections, and compressions, horizontal shifts, and vertical shifts. So now we're just going to apply these a little bit, okay? Find the equation of the final function after the following transformations are applied to the graph of y equals x squared. Verify using a graphing utility. So we have y equals x squared, shift right 3 units, reflect about the x-axis, shift down 2 units. Okay, that is the order you want to do it in. So you want to do the the horizontal shifts, stretches and compressions they did not ask about. Then you want to do the reflection, and then you want to shift up or down. So that's good. So x squared shifted right 3 units. Shift right 3 units. Shift right 3 units means we're going to put a -3 inside the parentheses. So that's going to become y equals x minus 3 squared. Shifted right 3 units. y equals f of x minus h is the graph of the parent function shifted right h units. Okay, that works. So that's shifted right 3 units, reflected about the x-axis. Look for reflected about the x-axis. Reflected over the x-axis means I turn the whole thing negative, okay? So that's now y equals negative outside the parentheses x minus 3 squared. If it was reflected on the y-axis, the negative would just be with the x. We want it outside parentheses because it's the x-axis. Shifted down 2 units. Down 2 units means we subtract 2 outside the parentheses. Y equals negative x minus 3 squared minus 2. Okay? Now it asks us to verify using a graphing utility. That just means start with x squared and then go to negative parentheses x minus 3, close the parentheses, squared minus 2. Is it shifted right 3 units? Yes, that point that was on the origin is now 3 units to the right. Is it reflected across the x-axis? Yes, the point 1, 1 became the point negative 1, 1, kind of, right? And then did it shift down 2 units? So from 0, 0, did we go down? 1, 2? Yes, we went down 2 units. So that looks correct. Don't worry. Last one. Describe the transformations and then sketch. So let's just look at what is the parent function. The parent function is f of x equals the square root of x, right? What does it mean if you have a 3 outside the grouping symbols? That means we are vertically stretching it. It's bigger than 1, right? So we're going to vertically stretch it by a factor of 3. So I'm going to say shifted stretched vertically by a factor of 3. And then remember, we're going in order. So we start with horizontal stretch or compression, go to multiplication, then go to a sign change, and then go to the outside plus or minus. Stretch vertically by a factor of 3, and then shifted vertically up 2 units, right? I guess I should put and. Good. So if we had, here's our original, right? We have 0, 0, 1, 1, 4, 2. Stretched vertically by a factor of 3. So that means all of those now go up 3. So that's 1, 3. And then this is 4, 6. And then shifted up 2 units. So that's again with the y. So 3 becomes 5. So now you have the point 1, 5. And then you have the point 4, 8. And you still have the point 0, 0. That would be my sketch of the graph. Here we have that same graph, f of x equals the square root of x. We are going to shifted horizontally, right, to the left. 2 units, because 2 units to the left is in the negative direction, and if we're dealing with the x, we're kind of doing the opposite. Shifted to the left 2 units. What does the negative sign outside the grouping symbols mean? Reflected over the x-axis. And shifted up 1 unit. Okay, so here's our original. So it was 0, 0, 1, 1, 4, 2. Shifted to the left 2 units. So that is now negative 2, 0, negative 1, 1, 2, yeah, 2, 2. Reflected over the x-axis. So this is my x-axis, so now I'm going to make all of my y's into the opposite. So from negative 2, 0, negative 1, 1 becomes negative 1, negative 1, 2, 2 becomes 2, negative 2, so that I can reflect it across the x-axis, and then shift it up 1 unit. So my final step is to move it up 1 unit. So 0, 0, I'm sorry, negative 2, 0 comes up 1 and becomes negative 2, 1, negative 1, negative 1, negative 1 becomes negative 1, 0. And then 2, negative 2 becomes 2, negative 1. Oops. Okay, I'm just gonna start over. So it was negative 2, 1, negative 1, 0, and 2, negative 1. Get complicated. There's my new graph. I'm just going to put it into Desmos to make sure we are correct. So 3 square root x plus 2. It does look like, oh, I forgot to shift the 0, 0 up 2. Okay, so that should be 2, 0, not 0, 0. That's why I use Desmos. And then 1 to 5, so let's look at the table. 0, 2, 1, 5, what about 4? 4, 8. Okay, those are points we had. Next one is negative, so I made one mistake, but negative, not but, caught it. X plus 2 plus 1. And I said my points were negative 2, 1, negative 2, 1, negative 1, 0, and positive 2, negative 1. Yeah, so that was okay. All right, and so that is how to transform parent functions. Thank you guys so much. Have a good rest of your day.